Ever struggled to track what messages your FastMCP server is actually sending to connected clients during execution? We'll configure the dedicated client-facing logger that automatically namespaces under FastMCP server context to client. You'll see how setting the debug level captures all structured log messages, including both the message text and extra metadata fields that get transmitted through the MCP protocol, while maintaining compatibility with Python's standard logging infrastructure for clients to process through their own log handlers. Import logging. From FastMCP utilities logging, import getLogger. To client logger equals getLogger. Name equals FastMCP server context to client. To client logger, set level equals logging. Debug. This demonstrates FastMCP's structured client logging configuration pattern. The code establishes a specialized logger that forwards messages from server-side tools to connected MCP clients, using FastMCP's utility function, which automatically namespaces loggers under the FastMCP hierarchy. Unlike traditional server logging, this pattern transmits structured log data through the MCP protocol, ensuring clients receive machine-readable messages with both content and context. The implementation works by configuring a dedicated logger channel that operates alongside normal server logging. When tools use context methods like ctx info or ctx error, FastMCP serializes these calls into structured messages containing MSG and extra fields, then transmits them via the MCP protocol. The client-side log handler function with signature async log handler message log message processes these messages, with log levels automatically mapped between MCP and Python conventions. The configuration shown enables debug-level verbosity for all client-bound messages while maintaining standard Python logging conventions. This pattern provides direct operational visibility from server to client, particularly valuable for interactive tools and debugging scenarios. By using FastMCP's protocol-based logging, messages maintain their structure even through proxy servers, while clients can integrate these logs with their own systems. The approach eliminates the need for custom logging transports while preserving full context, making it ideal for distributed applications where client awareness of server operations is critical. Let's break it down line by line. Import logging. This imports Python's standard logging module, which FastMCP extends for server-to-client log forwarding. The getLogger utility automatically prefixes the name with FastMCP, lowercase, creating a hierarchical logger, here named FastMCP server context, to client, that transmits structured log messages with MSG and extra fields via the MCP protocol. Setting the level to debug ensures all messages are captured and forwarded to connected clients, which must implement an async log handler message log message function to process them. FastMCP handles level mapping between Python and MCP logging systems, preserving context even through proxies. From FastMCP utilities logging, import getLogger. This imports FastMCP's getLogger utility, which automatically prefixes logger names with FastMCP to create hierarchical loggers. The utility standardizes logger creation across the system while preserving context through proxies. The logger transmits structured messages with MSG and extra fields through the MCP protocol to clients that implement the required log handler function. Level mapping between MCP and Python's logging ensures consistent severity handling across the connection. To client logger equals getLogger. Name equals FastMCP server context to client. This initializes a structured logger for server-to-client communication using FastMCP's logging system. The getLogger utility automatically prefixes the name with FastMCP. To create the full hierarchical logger, FastMCP server context to client, ensuring proper namespace organization. Log messages are transmitted through the MCP protocol as structured data containing MSG and extra fields, with levels mapped between Python and MCP using logging level map. Clients must implement an async-def log handler message, log message, function to process these messages and integrate them with their own logging systems. To client logger, set level equals logging, debug. Configures the servers to client logger to emit debug-level messages through FastMCP's structured logging protocol. The getLogger utility automatically prefixes the name with FastMCP. To create the full hierarchy, FastMCP server context to client, ensuring proper namespace integration. Messages are transmitted as structured data with MSG and extra fields, requiring clients to implement an async-def log handler, message, log message, function to process them, with level mapping handled automatically between MCP and Python logging systems. FastMCP structured logging bridge. This code establishes a dedicated communication channel for server-originated log messages using FastMCP's utility logger system, where getLogger automatically prefixes the name with FastMCP. To create the fully qualified logger path, FastMCP server context to client. Messages flow as structured payloads containing MSG and extra fields through the MCP protocol, requiring clients to implement an async-def log handler, message, log message, callback to receive and process them. The debug level setting ensures maximum visibility, while the actual log level conversion between MCP and Python systems happens via a level mapping dictionary like logging level map in the client handler.
The server's whisper becomes the client's voice, yet neither owns the word.